Good afternoon, it's Jeremy. It's Monday, December the 28th. It's a gloomy, freezing day in Toronto here, and I'm just going to look here at a GPS antenna. This is a patch antenna. It's designed on a printed circuit board, and you can tell, since it has a very, very thin lead-in, that it's an active antenna. The GPS works at 1.5 gigahertz, so if there was not an amplifier in the antenna, you'd never be able to listen to anything with this coax because it's too thin. You'd lose all your signal there. So there's an active device inside the antenna giving you about 25 to 28 dB of gain. So what we're going to do is we're going to go inside and we're going to look at this connection, the GPS connection on OpenPlotter. In the previous post, we looked at the installation of OpenPlotter, and today we're going to look at GPS on OpenPlotter and how to connect it remotely to your computer. So let's go inside. The receiver I'm going to use, this is an old one. It's kind of like me. It's from I think around 2000, 2004, something like that. It's a Trimble 12-channel receiver. It's got the IC inside and some other networking chips like a UART. And there's where the antenna connection that we just saw outside, and this is the USB connection to the computer. Now, in my previous post, I used a Raspberry Pi 3 on next to my TV, which is over here. So that's the one we loaded OpenPlotter on last time, and I used the keyboard and my TV monitor to do some work on the Raspberry Pi. Here, I've got the Raspberry Pi 3B inside what's called a Pi Top. A Pi Top is a very convenient little laptop that you can use for development. So it's got a proto board here connected to the GPIO of the Raspberry Pi 3B. Actually, this is a Raspberry Pi 3B Plus. And here I've got a SD card with the, they call it the Pi Top operating system. So if I'm not using OpenPlotter, I can switch the SD cards right away. So I use this setup to do development on software radio, and specifically working with synthesizers and stuff like that, where I use Python, programming in Python. I put the device on here and have easy access to the GPIO. So in the last post, we installed OpenPlotter. So today what we're going to do is we're going to remote the Raspberry Pi to my Windows 10 laptop. So the way we're going to do that is up in the top right hand corner here, we have a VNC server. So if I click on that, there's VNC server, and over here it has the IP connection, which is 192.168.0.12. The Raspberry Pi is connected via an Ethernet cable. There's the Ethernet cable, and it's connected to my ISP router down there. Okay, so we're going to go over to the Windows 10 laptop, and we're going to work from there. Okay, so now we're on the Windows 10 laptop, and we're going to remote the Raspberry Pi. So the first thing we need to do is, on the Raspberry Pi you have VNC server. So what we want on our laptop is we want VNC viewer. So here we are at realvnc.com, and you need to download the viewer. You don't want to put the server on your laptop, you want to put the viewer. If you put the server, you're going to have to get an ID and log in and all sorts of stuff. But with the viewer, it's just a free download. So you download the VNC viewer and you install it. So I've already done that. So let's just see what happens when I activate the viewer. So I'll just type in here VNC there. So there's the viewer. Okay. So I previously entered the address of the VNC server on the Raspberry Pi, which is 192.168.0.12. So there it is. If you're doing it for the first time, you're going to have to log in. So when you install OpenPlotter, just after OpenPlotter installs, a bit of Raspberry Pi comes on, the Raspbian, and it asks you a few things, like for instance, set up your country, set up your keyboard language and layout and time zone, etc. And in there you have an option to set up your password. So I kept the username Pi and my password. I'm going to enter it now. Okay, so there we are. So that's amazing. So I'm sitting at my Windows laptop and I'm controlling the Raspberry Pi remotely. So on a small craft, you could have all your navigation system connected to basically the Raspberry Pi sitting somewhere convenient, and then from time to time you can log in there with your laptop, or you can do it wirelessly, which we'll do at a later post. But today we're just going to use the Ethernet connection. So there we are. Okay, so what we want to do now is we want to connect the GPS. So the first thing I do is, since I have an older GPS, I want to make sure that the FTDI driver installed correctly. So I'm going to go to Accessories, and I'm going to go to Terminal just to see if it's in there. So let's look here. So if I type in dmessage bar grep FTDI, it'll tell me whether it sees an FTDI device, which is the driver for the Garmin, the Trimble GPS. So there we are, TTY USB 0, that's where it's connected. So now I'm going to use the terminal PuTTY. If you don't have PuTTY installed, I don't think it comes with the OpenPlotter. It's very easy to get. You just type in sudo space apt space install PuTTY, and it'll install it for you. It's just a small terminal program. So I'm going to run PuTTY and see if I'm getting the correct output from my GPS. So it's TTY USB 0. That's its address, and it works at 4800 baud. So let's see if I'm getting anything. Aha. So there we go. There's the output of the PuTTY screen, and you can see that I'm getting my NEMA 0183 codes. So the GPS is working correctly. Sometimes I don't get anything coming out of here. I get some garbage. So what I have to do is pull the GPS out of the USB and put it back in again. You might have to do it 1 or 2 times to get the older FTDI driver to sync up. Anyways, it's working perfectly now. So the next thing we want to do is we want to see this on OpenCPN. So we're going to use the features of the OpenPlotter. So I'm going to go in here into OpenPlotter, and I'm going to go down to Serial, and we're going to make a connection to the server, the OpenPlotter server. So there we are. There's TTY USB 0. So that's my GPS unit. I'm going to give it a name. I'm going to call it GPS Trimble or Trim. I think you're allowed up to 6 characters, or there's a limit on how many letters you can have in this name here. Or maybe it's 8, I'm not too sure. The manual tells you you can't have like 20 letters in here. It's got to be a simple thing with, I think, up to 8 letters. So there it is, and we want to specify that it's NEMA 0183. There's 2 NEMA codes, the NEMA 0183, which a lot of people use, and the NEMA 2000, which a lot of people use, but each one seems to have their own standard. So 0183, we're going to be safe here. So let's apply that. Click Apply. Notice it says applying the changes. So green means it's done. So now we go to Connections, and let's highlight this, and let's add it to the SignalK server here. And we have to put in the correct baud here, so we'll put in 4800, and then just use auto. It seems to work well. Notice it takes a while to set up the server, has to restart. Okay, so now it's green, so we're all set to go. Now in OpenCPN, OpenCPN comes with OpenPlotter, but one thing you might want to do is set up the maps. Just let me quickly show you how to do that. So there's the file manager. Look for your Pi. Pi is the home directory here. So there's Home, Pi. Double click on Pi. Now I put my charts under Documents. So in here, for instance, I have the RMCEN03. Those are the Canadian charts for the Toronto up to along the St. Lawrence River. So I put them in there. You can put them wherever you want, but that's where I put them. And then you can load them in OpenCPN. Okay, so let's go to OpenCPN there. So there's Toronto. If we go here into options, charts, I've got various charts loaded here. I've got the charts for Puerto Rico there, and I've got the worldwide chart there, which is free. I've got it set up, and if you look at, like, say, there's my directory here, pi documents / charts. Okay, that's where I got my charts located. And let's go into connections now, and we're going to make a connection. So we're going to say add new connection. It's going to be SignalK. That's the OpenPlotter server. Okay, and I'm going to say apply and OK. And let's see what happens. Aha, presto. So there's my boat. Boat stuck on land here at VE3 PKC. That's my latitude and longitude, so it'll be 43.7098, 79.4013, and those are the GPS strength bars. Now, the other thing you can do is you can, if you don't want to use, let's say, the server, you could, let's say, unenable that and add another connection, and we go directly. We could say, let's go serial, and let's go directly to the GPS. So I'm going directly now without going into the server. So that's another thing I could do. The advantage of doing that is I can also show the NEMA debug window as well. The debug window doesn't show when you're using the K server, but it does show when you go direct. So there we go. So there I am. There's my location. Those are the signal strength bars, and you can see the debug window. So there we have it. We've remoted the OpenPlotter to a laptop, and we've installed GPS in two ways, using the direct connection to the USB port, or we can use the server connection.